We're going to be looking at example 3 in our section 4.5 notes. A rancher plans to make 4 identical and adjacent rectangular pens against a barn, each with an area of 100 square meters. So we already have that picture drawn. We'd like the dimensions of each pen that minimize the amount of fencing that has to be used. Okay, so I'm going to go ahead and label all of these sides of the pen X. Okay, and then all of these little sides over here, Y. Okay, so I want to minimize the amount of fence that must be used. That's going to end up being my goal equation. That's a perimeter issue. So if I go ahead and add all of the blue that I have there with my X's and Y's, I get 5X plus 4Y. Okay, so my constraint is that each one has an area of 100 square meters. So I know that 100 is equal to, if I look at the area, it's X times Y. Now I'm going to use this constraint equation to get rid of one of my variables. It doesn't matter which one. I'm going to go ahead and solve for Y. So I get that Y is 100 divided by X. Okay, plugging that in over here, it's going to be all about X. Now I'm going to get 5X plus 4 times the quantity 100 over X there. So I'm going to end up with 5X plus 400 over X as my perimeter equation. So now I'm ready to take the first derivative. You may want to write this part of it as X to the -1 just to help you take the derivative a little bit easier. So the derivative ends up being 5. Okay, dropping this down, you're going to get minus 400, and then X to the -2. Okay, and all of that is equal to 0. Okay, so finding our critical point, I'm going to get 5 equals. I'm going to move that over to the other side of the equation. I'll get a 400. At the same time, I'm going to move this down. So I'll get X squared instead of X to the -2. Okay, so cross multiplying here, I get 5X squared equal to 400. Dividing by 5, I'll get 80. So taking the square root, and I definitely want a positive square root since we're talking about fencing here. I get the square root of 80. Rationalizing that a little bit, let's see here. I think we have 16 times 5. So this ends up being 4 square root of 5. All right, that's my critical point. So looking back at my perimeter equation here, I can see that definitely X has to be greater than 0 because division by 0 is not allowed. Okay, and we're not going to really worry about finding this side because whatever we find in something in a function that looks like that is going to end up being an absolute minimum for us. Okay, so 4 square root of 5 is here. Picking a number like 1, plugging it in, we're going to get a negative number. Okay, if we go on this side of 4 square root of 5, pick something, you know, like, I don't know, maybe 15. Okay, and plugging it in, you're going to get a positive number. Okay, so now we can see that we're decreasing and then increasing, so we do have a local minimum, and like I said, because of the way this function is, it's an absolute minimum. So X equals 4 square root of 5 meters is what we want for the X coordinate, okay, or for the X side of the pen. Okay, we plug this into our constraint equation to find Y. We get 100 all over 4 root 5. Okay, so we can go ahead and rationalize, multiply both by the square root of 5. Okay, so we had 100 square root of 5. Okay, and then we'll have 4 times 5, or just 20 there. And then 120 do reduce to give us 5 root 5 meters. And that does it for example 3.